Hello everyone, welcome to the subject of microcontroller. This is Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvatibai Ganba Mujhe College of Engineering, Waguli, Pune. So today in this lecture we are going to study about serial port communication of 8051 microcontroller. So let's begin. For communication between two computer system, we can send and receive the data bits serially. The microcontroller of 8051 supports full duplex serial communication. A full duplex asynchronous serial interface can be implemented on using serial interface control security. So first of all, we will see what is the serial communication and what will happen in the serial communication. In the serial communication, the data type, here the data is 8-bit in 8051 microcontroller. The 8-bit data byte must be converted to serial bit using parallel in and serial out shift register, and it can be transmitted over a single data line. At the receiving end, there must be serial in parallel to shift register to receive the serial data and then turn them into a byte. Serial communication is slower than the parallel communication. If the data is to be transmitted on the telephone line, it must be converted from ones to zero to audio tones, which are sinusoidal shape signals. This conversion is performed by the peripheral devices called modem. That is, modular and demodulars are called. When the communication distance is short, the digital signal can be transmitted it on simple wire and requires no modulation. What is the meaning of parallel communication? In the parallel communication, the number of lines required to transfer the data depend upon the number of bits to be transferred simultaneously. This is the parallel communication. What will happen here? The number of lines are required to transfer the data depend upon the number of the bits. The information is simply grabbed from the 8-bit data bus of the sender or transmitted to 8-bit data bus of the receiver. The parallel communication works only for shorter distance. For longer distance communication, long cable dimension and even distorted of the signal will be occur. The data transmission over a long distance using parallel communication is impractical due to increase in the cost and capability. Parallel communication is faster than serial communication. For example, data transmission from computer to printer. These are the examples of parallel communication. In serial data transformer, the data in a serial communication may be sent in two ways. One is synchronous and other one is asynchronous. In asynchronous serial data communication is widely used for character-oriented transmission. Each character or data is placed in between start and stop bits. This is called framing. The start bit is always 1 bit, but stop bit can be 1 or 2 bits. The start bit is always a low followed by the character and 1 or 2 stop bit high. Those are called mark. The ASCII character, a 8-bit binary, is formed in between the start bit and single stop bit. The LSB is sent out first. When there is no data transfer, the signal is high, which is referred to as mark. The low is referred to as space. A asynchronous serial communication peripherals chip modem can be programmed for data churn, which is 7-bit or 8-bit wide. While in older system, ASCII character were 7-bit. In the recent year, ASCII character are 8-bit. Assuming that we are transferring an 8-bit ASCII character using one stop bit and one start bit, the total 10 bits of each character, therefore, each 8-bit character, there are extra 2 bit which given 20% overhead. The rate of the data transfer in a serial communication is start in bit per second, or another widely used terminology is baud rate. What is the baud rate? Baud rate are not same to the bit per second. The baud rate is the modem terminology and is defined as the number of signal charge per second. In modem, the signal change of the signal sometimes transport several bits of the data. For conductor wire, a baud rate and bit per second are the same. So for this reason, we use the term bit per second and baud rate interchangeably. The baud rate in the 8051 transfers and receives the data serially at many different baud rates. The baud rate in the 8051 is programmable. A standard crystal frequency is used to generate the baud rate. The 8051 divides the crystal frequency by 12 to get the machine cycle frequency. The 8051 serial communication UART circuitry divides the machine cycle frequency, then feed to the timer 1 to set the baud rate. The 8051 baud rate is set by the timer using mode 2. To get the baud rate compatibility with the PC, we must load TH1 with the value I've shown in the figure below. The 8051 is a serial data communication circuit which uses a register in SFR. SFR means special function register called SBUF to hold the data. The SFR register SCON controls the data communication, and the SFR register PCON along with the timer 1 control the data rates. Here the SCON controls the data communication and PCON along with the timer 1 control the data rate. The SBUF is 8-bit register used serial communication in 8051. The SBUF register comprise of 2 registers physically. One of them is write only and used to hold the data, then is transmit out from the controller. How? Via TXT pin. While the other is read only and hold the data that is received from the external source via RXD pin. The double buffered receiver is used in circuit so that the receiver can receive the second character when first one is in immediate register or intermediate register. The double buffering reduces the chance of overrun error and complexity. But if the previous byte is not read when the next byte is completed its reception, the first byte received will be lost. Here the figure below shows the SCON register. What is SCON register? SCON is a 8-bit register. Serial data communication is a relatively slow process. In order not to tie up with valuable processor, serial data flags are introduced in SCON to aid in efficient data transmission and reception. The serial data flags in a SCON are TI and RI are set whenever the data byte is received or transmitted. Here these two bits TI and RI, these two bits are used for or set whenever data byte is received or transmitted. These flags are all together to produce an interrupt to the programmer and indicating that the byte is received or transmitted and hence to get the ready for the next byte. The program must read from these flags to find out which bit has created and interrupted and clear the bit. The transmission of serial data bit begin anytime data is written in SBUF. TI is set to 1 when the data bus has transmitted and sign that the SBUF is empty and other byte can be sent. The reception of serial data will be begin if they receive enable bit REN in a SCON. This is the REN here. The reception of the serial data will begin if the receive enable bit in the SCON is set to 1 for all the modes. In addition, the mode 0 only RI must be cleared to 0 and RI is set to 1 when byte is received in all the modes. REN is the only program control to prevent or to receive the serial data. Here the figure shows the SCON register. Here the MSB bit of SM0 and SM1. These two bits are used for specifying the serial port mode on which mode the register is in operating. Here SM2 enables the multiprocessor communication feature in the mode 2 and mode 3. In mode 2 and 3 or 3, if SM2 is set, then RI will not be activated. If the receiver data bit RB8 is 0, in mode 1, if SM2 equal to 1, then RI will not be activated if valid stop bit was not received. In the mode 0, the SM2 should be 0. Here REN is enable serial reception, which is set by the software to enable the reception or clear by the software to disable the reception. Here TB8 is the 9th data bit that will be transmitted in the mode 2 and 3, set and clear by the software as desired. RB8 is mode 2 and 3. In mode 2 and 3 is the 9th data bit that was received. In mode 1, if SM2 equal to 0, RB8 is stop bit that was received. In mode 0, RB8 is not used. means concept of stop bit will be default with the later in this section. TI is transmit interrupt flag, which is set by the hardware at the end of 8-bit time in a mode 0 or at the beginning of the stop bit in the other mode. In any serial transmission must be cleared by the software. RI is receive interrupt flag, which is set by the hardware at the end of the 8th bit time in the mode 0 or halfway through the stop bit time in the other modes. In any serial reception except SM2, which must be cleared by the software. Next come to the PCON register. Here the PCON register is not a bit addressable. It is used for controlling the data rate. The bit rate can be doubled if SMOD bit is changed from 0 to 1. Here SMOD, this is 7th bit of the PCON register, which doubles the baud rate bit rate. The baud rate bit which is set to 1 and timer is 1 is used to generate the baud rate, and the serial port is used in a mode 1, 2, 3. And the 4th, 5th, 6th of the PCON are which are reserved, and PCON 3rd bit is named as GF1, which is a general purpose flag. And GF0 of the PCON, which is also general purpose flag bit, and PD, which is PCON first bit, which is a power down bit. Setting this bit activates power down operation. Ideal bar, which is 0th bit of the PCON. Here ideal mode bit, which setting this bit activates ideal mode operation. The serial interface can be operated in 4 different modes that can be configured using SCON or serial port control status register. The mode 0, which is called as shift register with a fixed baud rate. Mode 1 is 8-bit UART with a variable baud rate. Mode 2 is 9-bit UART with a fixed baud rate. And mode 3, 9-bit UART with variable baud rate. The mode 2 and mode 3 have special provision for the multiprocessor communication. That is, we can have master-slave configuration. The baud rate for the serial mode can be adjusted, and the clock source required for the setting baud rate is provided on the chip. The baud rate is fixed for the mode 0, while it is variable for the mode 1, 2 and 3. The variable baud rate are determined by the timer 1 overflow rate. The mode 0 is a half duplex synchronous mode. It is referred as the shift register. The shift register has shift the left and shift right operations. The shifting operations of the data bit is sequentially done. The input to the shift register is a data and clock. The serial data is transmitted and received through the receiver line. The clock is generated by the transmitter line, and the transmitter shift clock is squared wave low of the state S3 and S4, S5 and the machine cycle. Here the S3, S4, S5 is the state of the machine cycles, while high for the S6 and the S1, S2 as shows in figure. Yeah. The 8 bits are transmitted at a time and start and stop bits are not required. The LSB of data is transmitted and received first. The microcontroller chip has limited number of input-output lines available. In order to increase the I/O lines, we can provide the external I/O chips like a shift register. Mode 1 is a full duplex mode. It supports 8-bit asynchronous communication. Whenever there is a change in a data 1 is transmitted, otherwise 0 is transmitted. Although the data bit is 8-bit, the number of transmitted bits are 10, that is 1 start bit and 1 stop bit and 8 data bits. Here, the number of total transmitted bits are 10, which includes 1 start bit and 1 stop bit, and except these 2 bits, 8 data bits. Whenever the character is serially transmitted, the transmitting and receiving devices should satisfy this communication protocol. In the mode 2, it supports the full duplex transmission with the support 11-bit asynchronous communication. Whenever there is a change in the data 1 is transmitted, otherwise 0 is transmitted, such an operation is called as non-return to 0 operation. In this mode, the number of transmitted bits are 11, that is 1 start bit and 9 data bits and 1 stop bit. The 9th data bit to be transmitted is to be stored in a TB8 bit in the SCON register and is stored in the RB8 bit in SCON when the data is received. The start and stop bits are discarded. The baud rate for the mode 2 is fixed and it can be expressed as 2 S mod divided by 64 into clock frequency. The mode 3 is similar to mode 2 except that in mode 3 the baud rate is determined as in mode 1 using the timer 1. In the serial communication, the baud rate at which the data bits are transmitted, which is called as baud rate. The baud rate is defined as bits per second or the change in the voltage level per second. The typical baud rate are 110, 330.